on the homework problem, but I thought it would be useful to just think about an RC circuit by using this one, because this is clearly some kind of RC circuit. Got both C and R. This is 18 volts at the top, ground at the bottom. Ground just means 0. That's just telling you that the voltage difference between the top and the bottom is 18 volts. So it drops 18 volts from the top to the bottom. Ground, you can identify anything you want as ground. Remember that that voltages are electric potential, and we got them from electric potential energies. And electric potential energies, you can set the 0 of the electric potential energy anywhere you want to, just like any other potential energy. The gravitational potential energy, 0 could be here, or 0 could be here, or 0 could be at the floor. And for exactly that set of reasons, the voltage anywhere in a circuit you could define to be 0. And everything else is defined with respect to that, either above or below 0, depending on what you called 0. If I called the top ground, then I would have to call the bottom here minus 18 volts, basically. So anyway, this is a ground. They just happen to call that ground is 0 volts, 18 volt drop across this. I am going to suggest that we hook up the circuit to the battery at t equals 0 with both capacitors uncharged ahead of time. So both these two capacitors are uncharged in advance of hooking up the circuit to the battery. I hook up the circuit to the battery at t equals 0, and I'm going to ignore this switch, so let's leave the switch open the whole time. So I don't care about the switch right now. So it's open, leave it open. So what I might ask you, I'm going to ask this question first, but what I might ask you is delta V, the 6 ohm resistor. There's a voltage across the 6 ohm resistor. Calculate the voltage or sketch the voltage as a function of time. Find it as a function of time. Voltage across the 6 ohm resistor, or voltage across the 3 ohm resistor as a function of time. I could ask for that one. Or I could put it all together. So there's 3 questions I wrote up here. Put it all together and say, how does the current through the battery change with time? There's a battery out here. The current through the battery gets split into 2 pieces. So then you'd have to calculate both of those currents and add them together to find the current through the battery and do the whole thing as a function of time. So it's a complicated, it looks like it might be a complicated kind of a problem. It might be useful to think about the individual pieces. And so I'm going to ask you to think about one of the situations, or one of the individual things that you might think about. Does the left-hand side or the right-hand side have the larger RC time constant? So if you remember for capacitors, come on, you turn into an eraser. If you remember for capacitors, a resistor and capacitor circuit, an RC circuit, that you get this exponential dependence when you hook up a single resistor and capacitor across an 18 volt or across a battery. What delta V is that a picture of? The resistor or the capacitor? Capacitor starts out uncharged. So got to be the resistor. What's the capacitor doing? Well, you have an RC circuit, so it's voltage plus the resistor voltage plus the capacitor voltage have to add up to a constant. the battery voltage. If you have a battery and you have R and you have C, so if you just have this, you just have R and C, then the battery voltage is constant, and the voltage across the capacitor and the resistor have to add up to that, one of Kirchhoff's laws, loop law. So that this is the voltage across the capacitor has to look like that for a single circuit. The time constant of one of these circuits is called the RC time constant. If you multiply R times C, you'll find out that it has units of time. So my question for you, does the left-hand side or the right-hand side have the larger RC time constant? So I've hinted at something that I haven't really said. The left-hand side of this is a resistor and a capacitor, and you hook it up across 18 volts. The battery puts 18 volts across the left-hand side, so it's the left-hand side with its battery acts just like an RC circuit all by itself. The right-hand side also 18 volts. So the right-hand side also acts just like an RC circuit. It has a capacitor and a resistor both. And I think the book did this so there wouldn't be complications. What did the book do? It took 6 ohms for this one, 3 ohms for this resistor, and then 3 microfarads and 6 microfarads. So R times C is the same on both sides. The time constant is the same for both sides. So the C, the dominant answer was C, and that's the case. The RC time constant, R times C, is the same for the left-hand side as the right-hand side. So if I plot the voltage across the So delta V across the 6 ohm resistor, well, it starts out, first of all, when you close the switch, the capacitor is uncharged, or when I hook up the battery, forget the switch for a second, for now, forever. When I hook up the battery, the capacitor is uncharged on the left here, and so that whole 18 volts drops across that whole 18 volts is dropped across the 6 ohm resistor. Similarly, when I hook up the battery, that whole 18 volts between here and here, none of it is across the capacitor, so it is also all across the resistor. So this is the same picture. It's got the same time constant, so it's got the same exponential time dependence, and they both voltages across the resistors start at 18 volts. And they go down in exactly the same way. And so if you were trying to find the current through the battery, well, the voltage drop across the 6 ohm is the current through the 6 ohm times 6. It's I times R. The voltage drops, so it goes down, but I don't care about the sign right this second. If I wanted to find the current as a function of time, I just take that voltage and divide by a constant, and so it's a picture that looks just the same. It takes the same amount of time to go to half the value for the voltage or for the resistance. This is just the current In the 6 ohm resistor, what about the current through the 3 ohm resistor? Well, the current through the 3 ohm resistor is going to be bigger because the resistance is smaller. So delta V across the 3 ohm resistor is just the same as delta V across the 6 ohm resistor. But the 3 ohm resistor has a 3 here, and so the current is twice as big. The current is twice as big everywhere. Then the current through the 3 ohm resistor is going to be twice as big as the current through the 6 ohm resistor. And the current through the battery is going to be the sum of those two. So that was just a little practice with RC circuits, but it tells you something about, I don't know, maybe we should take a step back. If the current through the 3 ohm resistor is twice as big, what does that tell you about how long it'll take to charge the 6 microfarad capacitor? Well, the current is twice as big. So you might think it would take half as long to charge, but the capacitor is twice as big. So it takes the same amount of time to charge that one fully. You charge it a lot more. The current is bigger over here on the right. So you charge it a lot more than the 3 microfarad, but the same amount of time. So these two have the same time dependence. Same RC time constant. So why did they do this in this problem? Why did they make the RC time constants the same? What if they weren't the same? What if this was 6 ohms, that was 3 ohms, and this was 6 microfarads, and that was 3 microfarads over there on the right? What if this on the right was 9, and on the left was 36 for the RC time constant? If you did something like that, you would end up with two things happening. The one on the right that had 3 microfarads and 3 ohms would be a very short time constant. And so it would drop off exponentially fairly quickly because the resistance was small, so there would be a big current, and the capacitance was small, so it would be quick to charge. So it drops off quickly, and the other one with 6 ohms on one side and 6 microfarads in the capacitance would take a lot longer. In fact, it would be an RC time constant that's 4 times longer. That's something like what I drew there. And so what would the total current through the battery look like? Well, the side with 3 microfarads and 3 ohms, the one that drops off quickly, would also have a much bigger current. There would be a big current that dropped off quickly, and then while that was happening, this smaller current would be dropping off. And so what you would end up with, I don't know how to draw this exactly, is 2 exponentials and not a single exponential. You'd have 2 exponentials for the current through the battery because the two links were dropping off with different time constants. And they wanted you to not have to think that that was a problem. Probably you would have never noticed it. You would have done their problem without thinking about it at all. I think I did. But just in case you thought too carefully about it, they didn't want you to have 2 time constants, I think. So I think that's why they chose those numbers. Any questions about RC circuits that's bugging you before I just move right along beyond them? Yeah.
So which way does the current flow? Is it just one current, one?
Which way does the current flow? The current flows from the high voltage side to the low voltage side?
Which way?
Both ways. They're both, because this RC piece is in parallel with that RC piece, because they're looped together at the top and at the bottom, they each have 18 volts across them, dropping. And so the current is down this side through there, and also down that side through there. So a current comes in here, gets split. Here it starts charging up the capacitor, and because the top gets positively charged, the bottom, in order to get negatively charged, has to have a current down like that through here. And so that current goes that way. This current, again, up at the top, you have a current here that's pushing these electrons here onto that and pulling electrons off of there. So both the currents are down the page, both sides, because both of them have a voltage drop down the page. And they're connected to a battery. That's what that 18 volts means. I've got a battery somewhere, I just didn't draw it. Any other questions about this or about RC circuits in general?